Hi everyone, really excited to be here at React Summit, and today we'll talk about how you can create collaborative VR environments using React and GraphQL. So let's dive in. A little bit about myself. My name is Vladimir Novick. I'm a software architect, author, entrepreneur, and I work in web, mobile, VR, AR, IoT, and AI industries. You can follow me on Twitter or check out my website for more information there. I'm also CTO and co-founder of EventLoop, and we create a robust, performant, feature-rich online conference experience that you really want to be a part of. We have our own conference running on EventLoop in March next year, and it's called Modern Web Summit, and you can check out more info about us on eventloop.app or follow us on Twitter for updates. So let's start. VR in the browser. So how it gets started, we started with WebGL, or was so-called like Canvas 3D back in the time, 2006, then continued into WebGL 1.0 spec, and now WebVR, WebGL2, and eventually it turned to be WebXR when WebVR was deprecated in favor of having both AR and VR in one API. As you can see on the Can I Use website, there's not much browsers that using WebVR or ready for that, so mostly just Firefox. So you cannot rely on WebVR or WebXR on Chrome. WebXR device API is also not that good, as you can see here, but it's work in progress, so we can envision that in upcoming years it will be better, hopefully. So what are our solutions today if we want to create some kind of VR experience? And I'm using Chrome here, and we'll still be using VR. So with WebVR and WebXR, if you don't have WebXR enabled in the browser, it defaults to like 3D environment and like game-like experiences and so on, which is also good. It's nice. We'll see it today. So with WebVR and WebXR, you can actually get your sensors positioning, you can get your headset positioning, and based on that, you can do interactions with the UI. For that, you can use different tools. One is for developing that. One is A-Frame, which is an amazing library and huge community that basically wraps around like 3GS and gives you lots of capabilities like physics, particle effects, movement, controllers, breakcasting, you name it, lots of things. And you can actually create really complicated experiences with that just by using its so-called anti-component system and using JavaScript. Now, if it uses JavaScript, obviously we can embed this in React as well, and we'll see today how it's done. Another option is just to fall back to best practices in terms of like game engines. We can use Unity game engine and develop something in C#, or we can use Unreal Engine and develop in C++, or their so-called feature so-called blueprints. But we are not here to talk about Unreal Unity, so we are here to talk about both A-Frame and React 360, mostly about React 360. So let's continue. Let's take a look at the A-Frame and let's look at the examples of experience that you can get. I don't have VR enabled here because I'm on Chrome, but I still can navigate the environment by pressing arrow keys and by just looking around this wall of basic shapes, right? So this is a nice experience, but it's not. It's just like really simple one, right? I want to see something more complex. So for more complex, let's get into directory of different examples, and one of such examples is Minecraft-like world, VR blocks. You can go around it, navigate, and it's pretty awesome what you can do just with the power of A-Frame and JavaScript, right? You can get all these cool stuff here. So apart from that, let's take a look at something more complex, something more like Beat Saber type of thing. If you played on like Quest or other devices, so we can get something like this also developed in A-Frame, and I think it's pretty nice. Also, music is kind of nice here. and you absolutely cannot create something like that in React 360. So with A-frame, you can do like really amazing and hypnotizing experiences, right? So pretty cool what you can do with that. Now, what A-frame uses? A-frame uses coordinate systems, and it not just A-frame. Basically, every 3D environment uses coordinate systems, and one of these, like this system, is basically either left-handed or right-handed. And the idea is if you take your hand and you point middle finger at you, so z-axis will be the pointed at you. So it means that positive x will be to the right side and the negative x to the left side. If you need to position something in front of the viewer, it will be minus z, and so on. So we use right-handed coordinate system. So when you see coordinates, keep in mind that we'll have these coordinate system both in A-frame, in React 360, and so on. So axis direction are also changed when applied rotation. So if we rotate something to the right, then all the axes change, and we need to take this in account. A-frame uses entity component system, which means it consists of entities, components, and systems. Entities are containers into which components can be attached. So you will see, when you will see it in the code, it looks more like entities are like React components. Components are like props, and systems are the global systems like services and stuff. So the reason why it's so, because in game engines, entity-component system is pretty common pattern, and A-frame kind of mimics that system. Unity uses also like entity-component system, so it's pretty close. So if we look at the A-frame code, we'll see something like that. Let's take it. So this just loaded. So I can like navigate around. I have these basic shapes, and as you can see, I need to just import A-frame, bring a bunch of styles, and then this is the scene component. These are assets component, entity, and I call it component, but in A-frame this is called entities. So these are entities, and like background, fog, and scale, not source, but like roughness, width segments, all of that are components. So it's kind of misleading because in React we used to the whole thing is component, right? And these are props. But in A-frame, in documentation, you will see these are entities and these are components. The main point of showing that is that you can easily see that you can just take this and abstract that into React component and start using it. Right, so there is React A-frame library, but I'm not sure it's maintained. I think it's not maintained for a while now. So you can just create wrappers yourself, and as you can see, it's just fairly straightforward here to pass different data to them and so on. So what about React 360? So React 360 is built for 360 user interfaces, hence the name. The main idea is that you don't create these like fancy experiences, you don't walk around, you just look at the curved screens and interact with curved screens in VR or in general in 3D environment on the web. So the architecture of React 360 is actually based on React Native architecture. We have React running in a web worker. When you bootstrap a new project, you will see in the index.js. This code doesn't have any access to browser APIs. It's just running in web worker. We have React Native Bridge that uses message queue to pass all the asynchronous messaging to the browser, to the client.js. Now on client.js, you need to define native modules, which are which basically have access to browser APIs. So to get started, you run npx React 360 CLI init. You get your demo up, and then you get these kind of components. So this is a client.js, the one that has access to the browser APIs. So you have the init function, you have a bunch of like React instance creation, and you pass a bunch of stuff, such as getting default surfaces, setting background to the whole environment, and so on. We'll see more complicated examples here, but this is like the thing that you will get once you create a new project. Now, what you can do now, you can render something on different surfaces, and there are several types of surfaces. The most important ones are the cylinder one and the flat one. Actually, it's supposed to be this one's supposed to be cylinder, but anyways, cylinder is a cylinder that surrounds you, and rendering something on top of this cylinder will have something curved in front of you, so it will be more will look better in UI. It's like the best practice in VR user experience, in VR design, to put flat UIs on curved surfaces so it will look more natural, so to speak. And if you put a flat surface, then it's just a flat surface that you can position however you want, like set an angle, and that's it. So to interact with the browser, you need to define different native modules. This is how we can define them. We import module from React 360, and we just define a class here, and we have the game state and game ID and user ID. And you'll understand in a bit what is this game state, because it relates to the demo I will show in the end of the talk. Then you basically register these modules, and you register them by adding native modules array here, and adding a function will get a context, and you can return a new game module passing the context back. So you can use the context to pass callbacks around and so on. So this is pretty cool thing, that you can create different surfaces, can create a game module to basically share your logic between different surfaces, because they are rendered like in different places basically. So on the React side, you use regular React components, and you use different components provided by React 360. For example, you have VR button, and you have different callbacks for that, like on enter, on exit, on click. Now, in VR, you have a concept of, in general, in 3D environments, you have concept of raycasting. When you project an invisible ray going into like specific direction, when it hits the target, it will return back the target that it hit. When dealing with VR controllers or VR headsets in general, there is a raycast projected from the camera or projected from the controller, and it hits the button or hits the target or hits something like that. So in React 360, VR button does that under the hood. So if you just look at the button, in VR, depends on the headset, or you point with a controller and enter the button space basically with the reticle of controller, then it will trigger on enter, or trigger on exit if you leave that. So it's like on mouse enter or mouse leave, but in VR. And we have like our component here, game tile, and that's about it. So it's pretty similar to React Native. We have views, we have like different like styles we can provide, like so for the buttons. There are specific styles for like positioning and so on. We can animate using animated, similar to React Native, and basically use practices we are aware of and using for several years. So what about the data? How we can bring in the data into our VR environment, right? And in addition to that, how we can bring it real time. Because we're talking about collaborative VR environments, we need to bring some data. We need to have like data updated constantly and so on. So for that, we'll use GraphQL, and GraphQL, as you all probably know, it's a query language for API, and it's like a magic that just works. And yeah, I'm really passionate about GraphQL. I talk a lot about GraphQL, so this talk is not different. We'll talk about that as well. So the idea with GraphQL is that we can send one request to the server and get all the data that we need, and the shape of the data will be the same as we requested. So it gives us a lot of benefits of having the data when we need and in the shape that we need, and having all the introspection of what is happening on the server. So this is how GraphQL looks like in like sandbox environment, a pretty simple one. And under the hood, we send in the query and getting the data back. The query is sent in stringified format with variables, and we're getting back the data in JSON. Now, this is more like realistic format, how it will look like in production. This is like Star Wars API. We have like different directives, we have variables, we have different types. GraphQL is all about types. So yeah, GraphQL is amazing, and we will use it for our talk as well. So what about architecture, and especially how about architecting something collaborative, right? So lots of things happening asynchronously. We have different third parties APIs. We have lots of things, like lots of moving parts. And obviously, architectural wise, we need to think about more like microservice architecture. So having different microservices here and third-party APIs and everything combined into one GraphQL facade that will return everything back. And the best practice, to my experience, is to use something like called the three-factor app architecture. And the architecture is something similar to that. You have an app which talks with the real-time GraphQL API. It updates some kind of state in the database or wherever you like, and we trigger event. Now, event will trigger a serverless function that will update the state and basically do the processing that it needs. And when state is updated, everything is propagated back to the client using subscriptions. So for our example, we will use Hasura, which is an open source and free engine, gives you auto-generated real-time API and on top of new or existing Postgres. And it has a bunch of features that I won't go through right now, but you can read that after the talk in the slides. There are lots and lots of features. This is just like the tip of the iceberg. To see in action our environment, we can go to Hasura console and see something like this. We have a game with a bunch of moves happening. We can see these moves, like subscription is running, and we get a bunch of data back. This is the subscription that I'm calling, and I always can insert a new move, and this will be updated. Now, what this serves, this backend serves this demo. So basically, I have a tic-tac-toe game, and I have here a bunch of, I can change my background, can change it from being a grid to being like a Skyrim background. I can have a chat, I can scroll on this chat. And the coolest thing here is that we have subscriptions in place and it's all real time. So for example, if I will click on something here, you see this one was updated, and let me click here. Again, I got another move. It updated here. Now in turn, if I will go and try to, and we'll stop that, we'll execute a move. Let's say we have a row number 0 and column 2. Let's write move here 0, 2. We insert a move. What will happen? Oh yeah, it's like array, so it starts from 0. So we have this one added, or let's add another one. Insert move, and you see everything is updated in VR and in real time. And this is pretty cool how we can do this with React 360 and Hasura together and create this kind of environment. And also, like, we can chat here. We can, the code is in GitHub, so you're welcome to look through the code. We will briefly look through that. but you're welcome to look more closely at the code and comment on that and so on. So how we add things to VR, how we add things, for example, here in A-frame, we basically add Apollo provider. We have our HTTP link, we have WebSocket link, and we wrap everything with Apollo provider. Now, here in A-frame example, it looks pretty ugly because A-frame is not built for something like this. It's built more for games and interaction. So I did like the other things around. Like the tic-tac-toe game was a game in React 360. In A-frame, it's like a blog post list in A-frame. So maybe it's a bad example. But anyway, you can go into like posts here and we'll get a subscription, getting all the data back. And you can see that you can change, you can update lots of stuff. It's different endpoints, so you will see different things here. So you're welcome to play around with that after the talk. How to add stuff to React 360. You add a poll provider, you add our game board, and basically you execute subscriptions, you execute queries. Now, before finalizing this talk, let's look briefly through the examples here, through the code here, sorry. And here we see our client.js. In client.js, we'll have multiple things. We'll have cylinder surfaces, surface flat cylinder surfaces rendering the whole game board. And we have our VR chat panel rendering on the right side of things, and game gallery rendering on the left side where you can change the background. And the whole logic is done through the native modules. Here we have one native module called game module, and it will be shared later on, right? Not now, but it's can be shared between this instance and other instances here. We have. Yeah, it can be shared like across the whole thing. We can also look into index.js. Index.js is registering multiple components. Now you have to register component, VR chat panel component, to use that, or game gallery. You have to register that, and because these are like different routes, and you basically wrap each one of them with a Apollo wrapper, and you can use subscriptions inside. So here I can render the board, and the whole idea with the board rendering is that I have the matrix that I go through, and I basically execute mutations whenever I click. One caveat though, React 360 unfortunately is not updated to the recent version of React, so unfortunately we cannot use hooks, so we still use like the old method of render props with mutation, and you have like component did mount and all of these stuff. I wish the hooks will be there soon, but it doesn't depend on me, so whenever it will be ready, it will be ready. Meanwhile, you can use A-frame easily with hooks and context and all the new React by just dropping A-frame components and so on. So let's get back here. And before wrapping up, I just want to first of all thanks for React Summit organizer for inviting me, and I want to basically encourage you to get into VR and AR and try things and try to create these amazing demos that were created for A-frame. Create amazing demos for React 360. Experiment, play around with the code. VR is just starting. It's just getting into the browser. It's still not supported everywhere, but it will be. So get into this stuff, try to learn new things, and thanks for having me, and enjoy the conference. Bye-bye. See ya.